Welcome to the Crazy Hat Chemist. So here we go with another awesome video of atomic structure worksheet number 2. So atomic structure worksheet number 2. That's right, folks. And before you actually start doing this worksheet, you need to make sure that you do one thing, and that is go to my YouTube channel, which you are already on. You're going to go to the Crazy Hat Chemist, the Crazy Hat Chemist. And at my YouTube channel, you are going to make sure that you watch the atomic structure collection of videos, okay? Before you do this. The other thing that you need to do is hopefully watch my video on atomic structure worksheet number 2. And that will give you many more examples. This is like an overall review. The other thing that you need to do is you need to pull out a periodic table. I'm using the periodic table from the SAT subject test from long ago. So yes, that's right, folks. So let's dive right into this and see what we can do. You probably need a working human brain and a calculator. So let's zoom on in. So what we're going to do is we're going to first figure out how to solve for everything that is on this table. Okay, so that will be the first part, the first step. So on this table here, what we're going to do is fill in all the missing parts, and then from there, then we'll go and do some other problems. All right, fantastic. So hopefully you have that calculator and that corresponding periodic table that I just aforementioned. All right, let's dive into it. So this one says platinum 201. This 201 is actually the mass of platinum. So this is going to be 201 for the mass of platinum. This is an isotope of platinum. It's not an average, if you will. Okay, and then what we need to do is find the atomic number for platinum. So that should be relatively easy. And so in order to do that, we're going to look for a mass approximately around 201. It won't necessarily equal that, but it will be in the ballpark. All right, so here's a periodic table. Let's zoom on in here and make this focus. There we go. So platinum, 201, 201, 201, where are we going to find it? 201, there we go. There is platinum right there. It's not quite 201. 201 is right around in this region right over here, but you should see that there is platinum. What I'm gathering from this is the symbol of PT and the atomic number of 78. So PT is the symbol. It's an uppercase with capital P and a lowercase t. And it said it's atomic number 78. So that's 78 right there. And this is a mass of 201. Okay, this is the standard nuclear notation. That's the AXZ that I'm just highlighting right there. And so A is corresponding to the atomic mass, and that's why that's right there. And Z is the atomic number. So this is atomic number of 78. Then we have everything here has a neutral charge. There is no charge on this here. And then therefore this number of electrons is 78. Because the number of protons and the atomic number are always the same. These are always equivalent to each other every single time. And since we have a neutral atom, then the number of protons, which are positive, equals the number of electrons, which are negative. Now what we have to do is solve for the number of neutrons, and this is going to be a simple problem here. We're going to take the difference between 201 and 78. That difference is 123, and that is going to go there right for the number of neutrons. Fantastic. So let's see if we can do the next problem here, the next square over. So in the next square over, what is given is right here. And that given information is really important, and we're going to solve the rest from that basic given information. All right. So this 40 right here is the atomic number. So this is 40 for the atomic number. The number of the atomic number is equal to the number of protons. That's also 40. The number of protons and the number of electrons are going to be equivalent here because we are actually dealing with neutral elements. Here there is no charge up in that little cloud area right there. And then we need to figure out the atomic mass. The atomic mass is 95. That's 95. That's right there. The difference between the 95 and the 40, that's a subtraction between the atomic mass. The atomic mass is the sum of the protons and the neutrons. So when we write this formula, AXZ, this A right here is the protons and the neutrons summed, and this Z is the proton. So as you can see, if you take the difference between these two, that is the atomic mass and the atomic number, then you get the number of neutrons. So I'm going to take 95 minus 40, and I am going to get 55, and that is the number of neutrons. Perfect. All right, now ZR is for zirconium, ZIRCONIUM, and then dash 95. That 95 is telling you the atomic mass. All right, cool. Let's go on to the next one here, and it says the atomic number is 55, therefore protons are 55, therefore electrons are 55. Okay. And then the atomic number of 55 lets you know what element it is. So what we're going to do is we're going to find element number 55 on our periodic table. That's right there. That's CS for cesium. So I can do CS, and that is atomic number 55, and that is cesium. Dash. And now what we need to do is get the atomic mass, and that number is going to go right here, and right here. It's going to be the same number, and that number is the sum of the protons and the neutrons, and so that's going to be 55 plus 82. And so that is going to be a 137. So 137. 137. So this is called cesium 137, and the atomic mass is 137, and it's cesium that is 137, and there's the 55, right? Perfect. And let's try the next problem here. The next one, we have atomic mass of 26. So that means that this is going to be a 26. This is going to be a 26. And then the number of protons is 13. That corresponds to the atomic number, which is 13. This is going to be a 13 right there. And since the protons are equal to 13, then the electrons are equal to 13. If I were to take the difference between these two numbers, 26 and the 13, I'm going to get the magic number 13. Everybody likes the number 13. It's my favorite number. Okay, and now what we're going to do is we're going to find element number 13 on our periodic table. And so atomic number 13, and that's Al, and that is for aluminum. So that's Al, and that's aluminum. So it's ALUMINUM-26, and that gives me the aluminum 26. Perfect. All right, so let's see if we can hammer out the next one. The next one here, what are we given? We're given the number of electrons. Since we're dealing with neutral elements, that is actually equal to the number of protons. The atomic number and the number of protons are actually the same number, and so that's 80. This is the number of neutrons is 118. So we're going to take the 118 and add that to the 80, and that will give the atomic mass, and that is 198. So the atomic mass is 198, and the atomic number is 80. And so now what we need to do is look on our periodic table for atomic number 80. And that is right here, and that is Hg, and that is for mercury. So that's Hg, and that's mercury. MERCURY-198. Perfect. All right. Let's see if we can hammer out the next one here. The next one, we are given the number of protons, which is 20. The number of protons and the number of electrons are the same, so there are 20 electrons. The protons and the atomic number are the same, so the atomic number is 20. The number of neutrons is 18. The number of protons is 20. I'm going to add these two numbers up, and that will give me 38. That is the atomic mass. So we know the atomic number, that's 20. We know the atomic mass, that's 38. So I need to go to my periodic table and find the atomic number 20 on my periodic table. Atomic number 20, and that is Ca for calcium. So that is Ca, that's for calcium, CaLCium dash 38. Perfect. All right. I'm hoping that is okay for you. That is actually the first half of this worksheet. We have now 3 more problems to do. So now the more complicated math problems. So hold on for that. You still need a periodic table, and you most certainly need a calculator for the remaining part. So I'm going to slide this on up here, and we're going to take a look at our 3 problems that yet remain. So these are our 3 problems yet remaining right here, and we're going to solve each one of these individually. Okay, so like I said, we're going to solve each one of these individually. I'm going to do each one on a separate sheet of paper so that you see all the steps involved, and that would be necessary for solving the problem. Okay, so let's see what we can do with this first one. This first one says europium is the most reactive lanthanide and has 2 oxidation states of a +2 and a +3. There are only 2 stable isotopes of europium. That's europium-151 with a mass of 150.919846 atomic mass units, and europium-153 at 152.9212 atomic mass units. Europium-151 has a percent abundance, has a 47.81% abundance. Calculate the average atomic mass of europium and compare this value with that given on the periodic table. So we have 2 naturally occurring isotopes. The average is equal to the percent in decimal form times the mass plus the percent in decimal form times the mass. So what are we actually solving for on this problem? We are solving for the average atomic mass. That's what we're solving for. Okay. All right. So what we need to do is we need to say the average is equal to the percent in decimal form of this first one is 47.81. So we're going to take this number, divide by 100, and I will get 0.4781. That's the percent in decimal form. And then the mass of that particular isotope. So that's 150.919846 atomic mass units. Plus, now I need to solve for the percent in decimal form of the other isotope. And how am I going to do that? Well, I have 2 isotopes, and their percentage equals 100, right? I only have 2 isotopes. They sum up to 100%, in other words. In decimal form, they sum up to 1. So that's 1 is equal to 0.4781 plus y. And y is the percentage of the other isotope. Okay, so I'm going to solve for y. I'm going to do a little subtraction there, and I am going to get the percent in decimal form of the second isotope. And so that is 0.5219. Okay. All right, then I am given the mass of that second isotope, and that's 152.9212 atomic mass units. All right, fantastic. So now what we're going to do is we're going to go back to our Algebra 1 skills, and we are going to solve this problem. The first thing that we're going to do here, if we're following the rules of PEMDAS, is we're going to multiply these 2 numbers, then we're going to add. So when we multiply these 2 numbers, we get the following numbers in my calculator: 72.154, 7783, 726, plus 79.809, 57428. Now I have not rounded these numbers yet, Okay, so what we're going to do is we're going to sum these numbers up, and we're going to get a number in our calculator. That will be 151.964352653. And now what we need to do is round. And how do we round on these problems? Well, the percentages add up to 100% or 1. So that means that the percentages in decimal form are equal to an infinite number of significant figures. Our last mode of mathematical operation is addition. So with addition, you're using the decimal places. So we're going to look at these two other numbers, which are the atomic mass units, the masses of each of those isotopes. We're going to look at those, and we're going to figure out which one has the fewest number of decimal places. So I have 1, 2, 3, 4, 5, 6 decimal places, 6 decimal places. And in this other second number, I have 1, 2, 3, 4 decimal places. 6 is more, so I'm going to use the fewest number of decimal places. That's 4. So I'm going to round this to 1, 2, 3, 4 decimal places. That means I am rounding with that 5. So I'm going to round this. I'm going to get the average atomic mass, and that's 151.9644 atomic mass units. This is my answer. Now, the second part of this question was, hey, find europium on your periodic table, and you should be able to correspond this average mass with what you find on the periodic table. So let's see if we can do that. Europium is right here. That is atomic number 63, and the average atomic mass on my particular periodic table is 151.97. And so that is very, very close to what we're getting on this one right here. So that's perfect. That's kind of like a check. Done. Okay. Perfect. All right, let's work on the second problem now that we've gotten this one solved very nicely. So let's see if we can do the second problem. Let's move this up just a little bit so that we can see all of this here. Whoops, a little bit too far. There we go. And perfect. Yeah, there we go. All right, awesome. So our second problem here, a little bit more complicated than the first problem here. It says lutetium is more abundant in the Earth's crust than silver. And there are only 2 stable isotopes of lutetium. What is the isotopic mass of the second isotope of lutetium when the first isotope has a mass of 174.940768 atomic mass units and is 97.41% abundance in nature? So again, there are 2 stable isotopes. The average is equal to the percent in decimal form times the mass plus the percent in decimal form times the mass. Perfect. So now what we're going to do is we are going to plug into here the information that we are given and what we're given in this problem. So what we are given is we have the mass for the first isotope, check. We have the percentage of the first isotope, check. We are asked to find, let's see if we can highlight that. What is the isotopic mass of the second isotope? So we are solving for this. That means that we need to solve for this percentage. And so that will be 100 minus 97.41. Okay, because I have 2 isotopes and they must sum up to 100%. So this will be 2.59%. We're going to write that in decimal form in just a moment here. The other number that we need to acquire is this average. And so this average, where is this coming from? This average is coming from the periodic table. So we need to find the element lutetium on the periodic table. And how you find this is you should be looking up a number approximately of a mass of around 175 or thereabouts. Doesn't have to exactly equal 175, but here it is right here. It's atomic number 71. There is the average atomic mass, 174.97. So I'm going to replace this value with 174.97. You should see that that number is coming directly from the periodic table. Perfect. Okay. So now we really have all the parts that we can have for this problem. We're going to substitute them into the equation, and then we're going to do our mathematical wizardry of solving this problem here. So let's see what we got. We have 174.97. That's the number that we acquired from the periodic table. Here's our percentage of the first isotope in decimal form. That's 0.9741. The mass of the first isotope is 174.940768 atomic mass units. And then we solved for the percentage already of the second isotope, but now we need to place it in decimal form. Now remember, when you're placing the percentage in decimal form, you're dividing by 100 or moving the decimal 2 places. So that means it's 0.0259. And then we are solving for X, which is the average of the second isotope. All right. So this is what we should have now. So now what we're going to do is we're going to do our mathematical wizardry, which really is not that too much of a wizardry thing. The first thing we're going to do is multiply here. We got 174.97 is equal to 170.409802.109 plus 0.0259x. Okay, and so hopefully that looks good to you. Now what we're going to do is we're going to subtract this 170.4098 blah 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 number, this entire number. We're going to subtract that on both sides. I'm not able to write the whole number there, but you should get the point there. We are subtracting that entire number on both sides. What we get is 4.560.197.891 is equal to 0.0259x. Now, what we're going to do is we're going to, again, solving this mathematically, we're going to divide by 0.0259, 0.0259. Now we're going to get x is equal to 176.069416641. Okay, so now what we need to do is round this number. Okay, so what we're going to do is we're going to go back to the original numbers, and I'm just going to underline original numbers, even if we solved for them. The percentages add up to 100%. So these two values are equal to 100% or equal to 1 in decimal form. So we're good there. Our last mode of operation was division to get this number. So we're looking at significant figures. So this number has 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. This number has 1, 2, 3, 4, 5 significant figures. The fewest number of significant figures is 5. So I'm going to round my answer. 1, 2, 3, 4, 5 significant figures. I'm rounding with that 9. That's 5 or greater. Add 1 to the preceding digit. 176.07 atomic mass units is the mass of the second isotope of Lutetium. All right, fantastic. Hopefully that one worked out well for you. That is that was a little bit more difficult to solve than the previous problem that we just did. But now what we're going to do is we're going to move on to our most difficult mathematical problem here, and we're going to nail this one down. So hopefully you got that so far. Let's get on a new piece of paper here. All right. And let's move this on up a bit. Here we go. Right. So our final problem here, and so thallium's name comes from the Greek thallos, meaning green shoot or twig. This characteristic green color is its atomic line, is in its atomic line spectra. Thallium has 2 stable isotopes, of which are thallium-203 at 202.972329 atomic mass units, and thallium 205 at 204.974412 atomic mass units. Determine the percent abundance of thallium 205. So again, there's two stable isotopes of this one here. And so that's going to be X bar, that's the average, is equal to percent in decimal form times mass plus percent in decimal form times mass. And typically, as you've noticed on the two previous problems, okay, this first one is the lower mass. This one is the higher mass that is second. So this is thallium 203, and this is thallium 205. So the question is determine the percent abundance of 205. So we are going to solve for this number right there, okay? That means that we need to know all the other components to this prior to solving it. So what are we given? We are given the mass of the first one, the mass of the second one, and that is here and here respectively, okay? We are not given the percentage of either. We are going to have to acquire this number here, that is the average atomic mass of thallium from our periodic table. And so what we need to do is look on our periodic table and find the average atomic mass. And it shouldn't be too difficult. So we are looking for masses, average masses between 203 and 205 approximately. And so that should highlight us on the periodic table. And here we are right there. And there is thallium. It's atomic number 81. So the average mass is 204.38. So this number here is 204.38. And that is the average atomic mass of the two naturally occurring isotopes of thallium. Perfect. Okay. So now what we're going to do is we are going to plug in our information that we need to here. Now, since this is the percentage that I'm solving for, I'm going to call this X. Okay. There are two stable isotopes of thallium. So let's do the next part here. We know that the percentages add up to 100%. So that would be 100 is equal to X plus Y. So if I were to divide by 100, I would get 1 is equal to X plus Y. Now, X and Y are in decimal form at this moment in time, right? So I didn't do X divided by 100. So we already said let X equal thallium 205. Consequently, we need to solve for what Y is equal to in terms of X. So what we're going to do is we're going to subtract X on both sides, and we have Y is equal to 1 minus X. Remember, the total is equal to 1, and so that's why it's 1 minus X and not X minus 1. So that means that this percentage right here is going to be 1 minus X, right there like that. And there are many students that have a difficult time of plugging this in or even understanding the 1 minus X. The 1 minus X, the 1 is the total, and it's minus X because that is actually equal to Y, which is the other isotopic percentage. Now, what you're going to do is you're going to make sure that it says what you're looking at is determine the percent abundance of thallium 205. What are you calling X? Thallium 205 must be X. And the other percentage is 1 minus X, not the other way around, okay? If you did solve it for the other way around, then you have to do a simple subtraction at the end, and that shouldn't be too terribly bad, okay? So now what we're going to do is we're going to plug all this information into our mathematical equation. So we have 204.38 is equal to 1 minus X, and then we need to write down the mass of thallium 203. That's 202.972329 plus X. That is what we're solving for, the percentage of the thallium 205. And we're going to write down the mass of thallium 205. That's 204.974412. Perfect. Now what we're going to do is we're going to do our mathematical wizardry here and use our Algebra 1 skills. And we are going to take this number and distribute it over both terms here and then multiply this right there like that. So, and writing this, we're going to have 204.38 is equal to 202.972329 minus 202.972329x plus 204.974412x. Now what we're going to do is we're going to do two things simultaneously in solving for x. We are going to combine like terms. This is an x term and this is an x term. Notice that I circled the sign in front of it as well. I'm going to combine those two terms with addition. I'm going to move this other term, the 202.97, to the other side with its opposite function, and that's subtraction. The 2 right there. Draw a line in the sand and let's see what we get right here. So we're going to get 1.407671 is equal to 2.0020883x. Okay, perfect. And then what we're going to do is divide by this number right here. 2.002083, and we are going to get x is equal to, and x is equal to 0.703103217999. All right, we're going to look at the original numbers that came from our problem here. And so this number here, oh, by the way, our last operation is the division. So that means with division, we're using the fewest number of significant figures. So significant figures, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 significant figures. Significant figures, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 significant figures. Significant figures, 1, 2, 3, 4, 5, 5 significant figures. Fantastic. So the fewest number of significant figures is 5. 1, 2, 3, 4, 5. I'm rounding with that 3 right there. That means I'm going to chop or truncate the number. The problem asked for determine the percent abundance. So I'm going to multiply this number by 100 to get the percent abundance. And that would be the following number, 70.310% abundance for thallium 205. So if you just happened to get another percentage, then I'm going to show you what to do. All right, so if you happen to get a different number and you're thinking, oh my gosh, I got it wrong, and this is a problem that many students have, then if you got the number of 29.690, that means that you actually called X, right? You set X here incorrectly, and you did 1 minus X here. But you actually solved for thallium 203's percentage. So no worries if you did that. You have to just take that number and subtract that number from 100 to get the other one. All right, so hopefully that worked out really well for you. We did a table. We did 3 problems, different mathematical solutions for those 3 problems. These are the important problems here on average atomic mass and using the periodic table. I can't emphasize enough, please watch my lecture videos on YouTube, the atomic structure collection, if you will. And please subscribe to my YouTube channel. I am the Crazy Hat Chemist, and I greatly do appreciate subscriptions and positive feedback, thumbs up, and comments. Thank you so very much. Appreciate it. See you next time, and have a great morning, a great afternoon, and a great evening. Bye for now.